we actually overtaken BMW, Mercedes, etc. So, and as our CEO says, so we are now only number 11 in the world from a brand perspective. So there is some way to go. So, and as we say, we will never stop before everyone is connected. So that's a bit basically about our mission. So what Deutsche Telekom does. But we of course here, like Nico said, T-Digital, so we are software guys. And I give you a bit of story, so before we just open our event. So, you know, the crisis is always, like we say, it's brings a lot of issues, but it's also an opportunity. So, but actually the crisis is the reason why we came here, so as a company. But it's, I think it's a very good start. So, give you a bit of history. So we're part in Russia as a software hub, one of the strategic locations to deliver soft for Deutsche Telekom for core systems, but also for B2B customers, for big customers like BMW, Mercedes, Volkswagen, Swiss Railways, etc. So, and actually when I joined the company, it was in a very cold 2004. So we were like 70 people. So, and actually when we started to close the company in 2022, it was 2,500 people. I just wanted to say that it was actually quite a long story. So what we managed on the market, and of course before this crisis happened, we were actually very proud to be at the company because we were, I would say, at least one of the best employers in the city because of the universities, because of the technologies, because of the community, because we are very reliable employers. So, and now I wanted to say that we came to Greece, and I think the good thing about that, so from one side we are very young, so we just registered our branch here in June, but we already like 450 people, so 400 people came from Russia, but we already actively hiring. So what I wanted to say, you know, we shortcut basically a few of our childish illnesses what you might experience when you start the company. So we brought a lot of experience. So, and that's why I'm like personally very happy to be here. So with all learnings what we took from our, you know, previous life, to bring it here to Greece, to make a wonderful cocktail of this experience with you as talents who are joining us here today in this meeting. So, and you know, it's our first pancake here, so let's do it right. You know, so that's and with that I just wanted to say that our purpose is here to be one of the strategic hubs, to do to become basically one of the most innovative hubs what we deliver, to be proud of this, to, you know, in the company, and very high ambitions for us to be like a good tech community in Thessaloniki, you know, for people who probably, I hope, no one leave the company, but even people leave the company, so we still can be together in such meetups and exchange ideas, technical ideas, experience, etc. And with that, actually, I wanted to, almost to finish what I wanted to say. So just enjoy our great speakers. So you will hear today about how we transform Deutsche Telekom in terms of how we bring the applications to cloud, how we go from our gigantic monolith systems to the microservices, and also the last but not least, how basically you might improve your experience and simplify your life in terms of documentation of the software. So with that, just enjoy this meetup, let's exchange ideas, be interactive, and we will never stop before everyone in this city is a part of software community in Thessaloniki. So thank you for your attention.
Anton is the product owner in the T-meetup project, and he will explain the future of telecom and how it will look like in his project. Anton. Yeah.
Καλησπέρα σας. Γεια σας. Milena Anton. That's actually all I can say now. Sorry for that. Nothing else. Yeah, so can you hear me well?
Yes.
I hope. Yeah, cool, thanks. As Nicholas said, my name is Anton Sinyushkin, I am product owner in T-meetup, and today we will talk about service management and orchestration in telecom. So our agenda, we will talk about classical operators networks, vendor lock, cloud-oriented approach, domain orchestration, open network automation platform, and about network automation platform as part of T-meetup, about service orchestration, and I will introduce the team that we have here in Greece. And I also have a question to you, just to verify how familiar you are with all that we are talking about, so I will have a few of them. So, what is the main business of our main customer, Deutsche Telekom? What is your guess?
Telecom?
Yeah, telecom, but to be more specific.
Voice, mobile, SMS,
etc. Okay, yeah, sounds like an answer. Actually, yeah, we do all this stuff about access to internet and also private or customers who we provide private solutions. So, in very general, the network of telecom operator, any of them, would look like that. So we have specific domains, which would be kind of core with IP/MPLS or WDM, and DWDM as a transport inside. We can have something like a metro backhaul, fixed access. This is actually our lines to fiber or whatever connection that you have at home, and wireless access. So the main issue which operators all around the world has right now is that for each of this equipment that we have, for this one, vendors should provide a specific ISICs. So it's CPU processor which is specifically designed to perform operations in exact part of network. So it's level 2 or level 3 of OCI model, and actually all the ISICs are designed for different purposes. So as you might imagine, there are a lot of different types of equipment, and it's all different design of ISICs over the network. If we will multiply the amount of ISICs to amount of vendors, we will get huge amount of different R&D that should be done to provide this. Also, if we need a kind of new feature somewhere in this domain or wherever, normally we should buy a new equipment. And that's a major issue that we have right now, that if we want to provide to our customers new features, we need to buy new equipment. And as you might imagine, it's a huge amount of money, it's huge costs that operators should take on their shoulders. And of course, it also relates to the costs of services. So my next question would be, does somebody knows what means Helm chart? Okay, so it looks like I should explain a bit. Currently, all the applications they provided in way that you have a YAML file. This Helm chart is taken from helm.com website. It's just an example. So it's an instruction for the worker how the application should be built. So the exact steps, what software to download, how many workers should be there, and how it will all interact with each other. So I just wanted to mention your attention that actually with such kind of Helm chart, you can get application wherever it is, but you also can get a kind of cloud native function which will replace the equipment that we've seen before. So, so the target picture would be that instead of all the equipment that we've seen on this picture, there would be a kind of cloud replaced with these CNFs. And these CNFs, it's actually a Helm chart which applied on the cloud and executes the same actions which is done by hardware, but the beauty of it that all the CNFs can be provided by different vendors as well. But what is more important, that all this can be done on basics of x86 platform. So we can use normal servers and normal clouds, and to use this compute capacity to provide to our customers services. Okay, let's go to the next slide, and how we do this in T-meetup. T-meetup is a network automation platform which is done for service and management orchestration. And by services, we mean here actually CNFs, which is provided by different vendors. And what we do, in classical radio network, we're gonna have the following parts: a BBU plus RU. It's a combination of equipment which is connected to the core, and there we have all the phone services. So when we take our phone and actually it interacts with these types of equipment. So we can replace this BBU one with CNF, with cloud native function that can actually perform the same operations, but it can be scalable, it can be more efficient in some ways of delivering new features, because it's just another Helm chart that we will roll out in the cloud. And it can be, well, more flexible. We'll talk about benefits a bit later. So now about ONUP. ONUP is an open network automation platform. Around 5 years ago, operators all around the world decided that they want to avoid this vendor lock that I've described before, and they created a platform which allows us to make automation, so to say, on common purposes. So my next question would be, does anyone knows what is LFN, Linux Foundation? Okay, so you might have heard about them 2 weeks ago. They announced metaverse based on open source code. Okay, so these guys, by the way, support T-meetup as well, ONUP as well, sorry. So it's open network automation platform. It was started, as I said, 5 years ago, and it's completely different from perspective of 5 years. That is, it was a very, well, based on very new technologies. It is model driven. It's cloud native, and of course it supports all the DevOps practices that are very fancy and popular, and actually colleagues probably further will tell you something more about them. This platform allows us to build applications for telecom, for managing services in different domains. For example, just let's move to technologies that are on it, and then we'll talk about who and how use it. So this is the list of technologies that actually used in T-meetup, and it's there are a lot of buzzwords, but anyway, most part of them are used in our half of the time is already used. I just want to mention not to make it too long. I can speak about it for hours. So you might see here that we have very fancy words, and it's just to illustrate that the most advanced technologies in IT market are used to build this platform and to develop it. So ONAP is pretty complicated on its structure, and it's modular, and different modules are used by different companies in different ways. So if you will go to Elephant site and watch, for example, demos from previous summit, you will see that the China Telecom, for example, uses some components to manage services in GPON fixed networks. Orange uses it in different way. Deutsche Telekom uses it in different way. So it's very fixed, not fixed, it's very plastic and very adoptable stuff. So we in T-meetup we use several components, and actually the key one is service orchestrator. It's a component that our team here in Greece is responsible for. We do an upstream contribution to community, of course, together with our colleagues from another teams inside the project. But anyway, this is our responsibility component. And we have, for example, here a very fancy one like control loop automation. It's the one which all the industry is willing to get. It's when you receive from cloud native functions performance data, and you adopt the settings of this cloud native function to provide more reliable or more quality service to your customers. And it's very crucial thing that you can do it online, and there are different types of closed loop automation stuff. SMO development, let's talk about T-meetup, how we build T-meetup is very common picture. So we have developed our own portal for users who are actually managing services. We have an orchestrator, I told about it, non-real-time rig component. It's actually about closed loop automation, but not in real time, but it takes some time to analyze, and there is also real-time rig components, but they're a bit more complicated. We have design studio, and all this via southbound interacts with radio units, with distributed units, and with central units, which is actually Kubernetes pods that are running in infrastructure. We have one more layer here. It's virtual machines in OpenStack, and then bare metal servers. And next slide I will show you is how we do instantiation, actually how the process of rollout of service to the customer looks like. So the first phase is planning, and actually it's a Helm chart which is in Git, and using this data we also plan what would be what we are willing to get as a service, and one improvement that was done with the T-meetup according to ONAP is that we roll out not each of the services one by one, but we do a kind of bundle which is called G-Node B. It's improvement that we've made, and it was presented to community, and very well accepted there. That's why they all are connected all together, just because it's easier to roll out them with a bundle of Actually, they replace BBU that we've seen on the first slides. So we do this blend nodes. After that, in service design and creation component SDC, we actually load Helm charts from, we generate them from model to and blend nodes. We generate Helm charts, and then we go to service deployment phase. Via portal operator actually press few buttons, and service orchestrator generates all the necessary activities to instantiate CUCP in actually cloud CUCP, CUP, DU, and radio unit. They all are connected, and then they are in inventory. Actually, that was shown. It's not a theory. It was shown on demo that we've done in Neubrandenburg in the north of Germany, and 4 sites were rolled out with help of this technology. And actually, after these processes, you can connect your device to RU, and you have rolled out a new network operator mobile. And actually, if you can imagine that within several clicks we can roll out an operator in Greece, or in Poland, or in Czech Republic, so that for me actually it's like amazing stuff, because it takes years to do this with hardware itself. Yeah. So, and this is how it will look like in portal. So it's a kind of tree structure that in Genome B you will have CUCP, CUP, DU, and radio unit, and some parameters inside. That's actually almost it. Also, this is flags of countries where we have in T-meetup colleagues from. So it's Germany, India, Poland, Czech Republic, and now Greece. And this is a team which we have in Greece. So if you will see these smiling faces in coffee break, you can stop them and ask them questions about the future of telecom. And many thanks for your attention.
So, hello colleagues. Yeah, as you can see, you hear me well. Yeah, so let me start maybe. And today I'm going to talk about migration from legacy, from our legacy to cloud. Maybe in the beginning a little bit about myself. My name is Nikita. I'm working in the company almost 4 years in a quite big project named FlexProd. FlexProd, this is about internet in Germany, and for now I think FlexProd maintain almost all internet in Germany. Of course, we have a new modern project like fiber, and it is ongoing, but for now still we have a lot of to be done in our FlexProd project. So maybe from the very beginning a small question to you, colleagues, and other people. Maybe, do you know what does it mean legacy or monolithic architecture? Can you please raise your hands who have ever heard about it? Okay, they can see many of you. So this will be very interesting today. So let me then start. This is the agenda. What about I'm going to talk to you today, and today I'm going to describe our project, our legacy, and how we make migration from the legacy to the cloud. This is not finished, it's still ongoing because we have a big legacy. So what is legacy for us, for our project? This is the WebSphere. Maybe you have heard about it something. So WebSphere, this is the IBM software product. This is the product that performs the role of web application server. As you can see on the picture, this is maybe the main picture of the WebSphere. Maybe more specifically, this is like a framework that could run Java-based web applications. So what is this, the WebSphere? This is how to understand. Do you work with monolith or just this is not monolith? Usually, when you work with the monolithic architecture, you have some kind of internal bus for communication. So all services that works in your application, in your web servers, they tightly coupled and they work as a single service. And usually this is the bottleneck in this application because of all services are tightly coupled and they all are interconnected and depends from each other. If one of the application could stop, it could stop all the servers. So what else to say about our legacy? So this is it, and I'm not thinking about it. It's very interesting to speak about the WebSphere. So now we are working with WebSphere using Ansible playbooks. We have a lot of them. So we describe, so Ansible, this is like the way to work with the servers and also with the services. And we start this Ansible using Jenkins. So this is the step which we are used to work with the legacy, with the WebSphere. Besides the legacy, we have our modern part with the microservices. And so how it starts? Maybe 3 years ago, our architects decided to move forward, and the process of planning had been started. And we decided to implement Agile and Scrum methodology to our project. So for now we have almost 14 teams, Agile teams, that develop our microservices. So for now all our developers, mostly they from India. So there we have Agile teams, Scrum Masters, so we have a lot of sprints, sprint reviews, and so on. And they develop the microservices for us. They use Spring Boot Java-based framework for microservices. All what they did now stored in Git, in GitLab. So what is this, the microservice? As you can see on the picture, so from the right side, when you work with the microservices, or maybe in other words, with the microservice architecture, the whole application built as independent components that run each application process as a service. So they usually communicate with the APIs, and the very important thing here that when you work with the microservices, each microservice usually perform a single function. This is maybe the importantest thing here, that when you work with a single function, you could easily test. Single service, you can easily deploy it, update, or do whatever you want. To work with the microservices, you need some infrastructure. So, you need the cloud. We have, I think, all of them, as Amazon, like Azure and so on. And as a big company, we have our internal cloud, and we, as a project, use a part of this cloud. And so yeah, we use a part of internal telecom cloud with pre-installed Kubernetes clusters. And to work with the cluster, we were free to choose any of user interface to work with it, such as, for example, I don't know, OpenShift or vanilla Kubernetes or Rancher. For us, it was Rancher, and we choose Rancher. This is like just a software to manage Kubernetes cluster. As you can see on the picture, this is one small part of our applications, microservices that runs in a single namespace. I can't zoom it. Yes. So here is the name of the namespace. We have a lot of instances of the legacy of the WebSpheres, and now we have also a modern part with the microservices. So we decided to connect them with the names, like integration for teams that test our services, and dev developers. This is for dev. This is part of int, so this is for our testers. Now this is the time for small demo. I'm going to show you how we work with the microservices. Sorry, give me a second because the mouse doesn't work on this glass. I'm gonna speak. Yeah, it's better now. So I'm gonna show you, not show.
Technical problems.
Okay. Thank God. Sorry about that. It's not easy really to connect it all. So I'm going to show you how we now work with the microservices. This is the Rancher, the user interface to work with the services, the orchestrator. I'm going to delete some number of the microservices, and then I'm going to install them to show what will happen. So as you can see, there was 6 of them, and now I delete 3, only 3 of them here. From the very beginning, I would like to describe our branching strategy. So to work with the microservices, we have 3 main branches. Develop features. This is the branch for something new. So when developers decided to invent something or develop, we create a develop feature branch for this service and all process of development there. When the process of development finished, we create develop PT branch. This is branch for process test, and test started. So when the test started and everything is fine, all bugs closed, we then create a tag, because tags if they are immutable. We create a tag with a specific name, and this tag is ready to be delivered. So how for now we work with the services? We have also, as we worked with Jenkins before, we decided also to use Jenkins here, but this is like only a starter. We have a job with all amount of our services. When we need something new, so we have a big amount of environments. I think almost 90 of environments of WebSphere. So each small WebSphere contains 40 Java applications, 40 legacy applications, and we have 90 of such environments. And for each environment, we could connect an environment with the microservices. So we will, if we want something new, we just specify the name of the environment. Then Ingress will install all Ingress rules. This is the full communication between services and also between other services. And this is the name of the service and the branch. The name, branch. The name, the branch. And we have, for now, we have 20 of microservices. I will just show you about 3 of them. So choose and then build. Maybe this is not very beautiful. We now go into a little bit recreate this picture. Very interesting. Ah, SVN doesn't work. So it could be. Yeah, and I have, okay. Okay, forget about it. About this pipeline, I have the last one. I will describe this one. So this pipeline starts the GitLab project, which looks like this. This is the multi-stage project, which contains from 3 steps. The first step, this is the preparation. When the preparation step is ongoing, so we collect some kind of variables and fill some kind of placeholders. This is the preparation for next steps. So the next step, this is the package. We create Helm charts. We work with Helm charts very much. So as my colleague described previously about the Helm, it's also a tool which we are using in our everyday life, and yeah, Helm is very useful here, and I highly recommend you to use it also because yeah, it is very simple to understand and very cool to work with. So on the second step, we create package, a Helm chart with all values, all variables, all manifest, and put it to our local JFrog Artifactory. So this is the repository which we are working with, and so yeah, we have in the end of this pipeline we have an archive with the Helm chart. And the third step, this is the process of deployment. We just pick up the chart from the repo and deploy it to the cluster. So pipeline could be look like this if it works. So this is the first step. This is a number of microservices, and this pipeline, when it finished with the success, it triggers the next one. This is the package one. The package will create the packages for all microservices which we have choose in Jenkins, and if all packages was built and pushed to repo, then the last step will start with the deployment process. Yeah, and so this is it, like preparation, package, and then build. And it could looks like okay if it works. So it was like 6 of them here, but unfortunately, guys, something happens. I don't know what. SVN is like a tool that's not working well, I think. Let's try to review this one. Yeah, okay, so forget it. This is about our, I can show you maybe not this one, but maybe like 01. It will look like this, for example, the number of microservices, and yeah, they are working fine. So this is about what we have now with the microservices, with this microservice architecture and how we work. And this is not the end. So what we're gonna do next? We decided to move forward and fully automate our process of deploying these microservices. And we decided to use Argo CD tool. So Argo CD is Kubernetes native continuous deployment tool. This is important here, that this is continuous deployment tool. And the main part here that Argo CD can pull updated code from repository and deploy directly to the cluster. Argo CD can maintain like GitOps best practices, and it allows you to work with pull and push models. So what is this pull and push model? Usually when you work with your code in, for example, for us GitLab, so you push something to your registry. For example, if you develop something new, you commit it or you merge, so your pipeline triggers by push. This is the first variant of working with the push model. The pull model allows you to work in a little bit different way. So when you would like to work in a pull model, you need an agent. So this agent will continuously run on the environment where you would like to deliver your code, and this agent will constantly ask your environment about the defined state, and the running state. And if the agent will find the mismatch between these two steps, these two states, yes. So it will pull the changes from the repository and deploy it to the cluster. So the model is very well known. We already use it. You can see on the picture. This is from our Separate project, and very soon we also will implement it for us. And this is it. So this is very briefly about the process of migration from legacy to cloud. We're not finished yet. A lot of will be done, and number of our legacy applications will be less and less, and number of microservices will be more and more. And yeah, this is it. Thank you very much for this chance.
A little bit prepared for that. Strange. Okay. Okay, let's start with my presentation. First, I'm happy to see all of you here today, and I will introduce myself. My name is Kirill Mitrofanenko. My name honestly comes from Greece, and in Greek it's called by Kyrillos. I think you know all of the guys, Kyrillos and Methodios, who brings alphabet. Yeah, that's the roots of my name. And today we will discuss with you about documentation. In most of the projects, it's an important topic, and I would like to ask you one question. Who likes to write documentation? Raise your hand. 1, 2, 3, 4. I suppose all of you is not developers. Is it true? Because I don't like to do documentation. Yeah, because it's not funny. When you do, at least in our project, most of the developers doing documentation, and we have no special role for that. Why I would say it's not funny? Because when you're writing code, you can see the benefits which brings your code. It doing I don't know, beautiful page, or it's doing some kind of automation, and you can see the result. But with documentation, you see only pages that you create and nothing interesting. How to do it a little bit more interesting, I will show you today with a tool called Sphinx. Let's go to the next slide. Let's skip agenda just to save some time for the general presentation. This is the tool which we will talk about today. This tool called Sphinx, as I already said, and it developed with Python. It makes some more benefits for it because it's easy to use. If you ever have to use Python, you know that install any application, just pip install, or any library, you need just pip install to also install Sphinx and all the extensions. That's all what you need. What doing Sphinx? It use as sources for documentation some kind of format RST it's restructured text. It's quite simple format. I will show you some examples of it a little bit later during my demo presentation. And I would say that to be an expert in restructured text, you need to Google 1 hour or something like that. It's enough, and you don't need any skills before. Things get these sources, and then in the end generate some documentation for you, which exists in the HTML format, which we take a look today, PDF, manual pages, EPUB, text info, and some more formats. Honestly, I don't know all of them, because mostly we are using it as HTML format of output files, because it's quite easy to put on any web server, and you will be able to use it. What other benefits has Sphinx? It has lots of extensions developed by Sphinx and also a third-party community. We can use all of them. We will take a look at 5, I suppose, today during my presentation. Next slide. It also has different themes. I like to say skins. It's just visual how it will be, how it looks like your website with the pages of your documentation. Yeah. Also, it supports pigments highlighter. It helps to put inside of your documentation part of the code. This feature supports, as far as I remember, 5,000 different programming languages. I suppose more than 5,000. I suppose you will easily find your language in this list. Sphinx support different structures, glossaries, cross links between pages of documentation, children objects, I don't know, some diagrams via extensions. You also can use plant UML, Meram ID. I also show them in my presentation. Okay, let's go to the next slide. Yeah, this one. Right now I will show you small demo with generate documentation into the 2 places. The first one will be GitLab pages. It's, if someone is not familiar with GitLab, we are currently using it in our company because it's we are huge corporation, and huge corporations like Enterprise Soft. That's true, and we are not excluded from this list. We also like Enterprise Soft, and we're using GitLab. GitLab pages, it's embedded feature in GitLab, it's just embedded web server, which can be easily used from the pipeline, and you need to put your artifacts into the server, and there it becomes to be available. You don't need to think about authentication, authorization, and so on. Only what you need to use it. That's it. And second destination, we will build the same documentation into the Confluence. It's Atlassian Confluence. Atlassian's a company who developed Jira, Bitbucket, also Confluence. Confluence like Wiki, if you're not, if you haven't saw it ever, just Wiki pages. Okay. Okay, that's my project. Just seconds, and I will show you simple example of format restructured text which we have used. I will make it bigger, I suppose. Yeah, that's a simple example of usage restructured text. For example, to build this header. To create this header, you need just to put 2 lines under your text, and it will be big and bold, and you can easily create the format of your documentation. Also, you can create different lists. I briefly go through this file because formulas, because you can easily find this information in internet. And it's quite, just trust me, it's quite easy to understand how it works if you ever use it. Wavefly to make italic. Okay, let's go next. Here we have how you can build your sources into the HTML files or any other format. You need to run Sphinx, and for that purpose I have here one single command, Sphinx build. Then I point source directory, destination directory, put it everything in one line, and start this file into my pipeline. Here I have only one small command, make, which is include all of the all what I said before, and format which we would like to have our documentation. After the build, we publishing this documentation into the web server just to put, just to move all of the artifacts into the folder public. And the third step for us will be push this documentation into the Confluence pages. This also can be done via one command simply. And let's look how it will be in pages first. Yeah, that's what we received. It's my just demo, simple project, which should have bug. We can see here that the path is wrong, and that's the reason why we have no picture in this place. This picture exists, but this one is not. We are going to fix this bug right now. Go to this file, just change it a little bit, start a new pipeline. Change the path to correct one. Commit. Right now, this pipeline was started. We are performing the build operation. Let's just look inside what's going on here. Yeah, what I forgot to mention, I suppose, for build we are using a Docker image. You can install Sphinx on your laptop, you can install Sphinx on the virtual machine, wherever you want, but just for pipeline we are using it in Docker. And, yeah, we have here custom image. If you would like to avoid support and patching custom images, you can use just an official image from the GitHub. It also works fine. Yeah, for my project, I use internally built. I build it by myself. Yeah, that's successfully built. We created some artifacts here, and right now, I suppose, was started. Yeah. We already delivered our code into the pages. Let's check was it fixed or not. Oh, sorry. Maybe we can do it this way. Update page. Oh yeah, we just updated the page here, and this picture appears. And now we are ready to deploy everything to our production for our customers. Let's say it this way. We will push it into the Confluence. Yeah, as you can see here, we use another image with the tag Confluence. This image just contains additional extension, Confluence Builder, it's called. And yeah, via this extension, we are publishing all our the same documentation pages into the Confluence. Just wait for a few seconds, and I suppose it will be done. The completion. And then, yeah, we have a link to the page which we generated. To log in at first. Login is correct. Yeah. And here you can see right now the same structure as we saw before in GitLab pages. This is the same structure. Let's go inside and you will see the same pictures, same text. It's a little bit different format because Confluence has its own format for the pages and we are not able to manage it at all, unfortunately. But we can see, for example, the difference that we have. We generated, I don't know, let's look here. This is a warning box and how it will look like in Confluence. It will look like this one. They look different, but in the end they contain the same text inside, and yeah. For me it's quite clear and understandable what we are going to say in this box. Yeah, it's just a design difference, but in the end it will be the same text, the same structure and so on. The same artifacts will deployed in the two different places. A little bit. Yeah, that's for example how you can create a spreadsheet in your documentation. If you put inside of RST file this view of the page or view of the spreadsheet, you will get in the end artifact this pretty good table. Yeah, okay, let's go. What I wanted else to show you, it's documentation of my current project where I'm working right now, and we have a little bit more than it was shown in the previous example. Yeah, it's introduction. Here. Yeah, you can see these pretty diagrams. It was made by extension called MiramID, and they are also fully described in text and was generated as a pictures here from the text. It also contains some. Suppose this one is not. This is just a picture. For example, you can see. This one was added as a draw.io file. I suppose most of you are familiar with the draw.io tool, and this diagram was created in draw.io, exported, and then via extension we are using it in our documentation. Oh, that's also a cool extension for the Sphinx. It's called git change log. For example, here you can see latest commits related to this web page, who and at what time done this commit, which was applied for this page. It's quite useful feature when you need to debug who was the latest guy who edited this page. You have commit SHA here, comment, and the person who did latest changes. It was me, for example. It was before it was Joachim Winter. Yeah, that's a little bit about extensions that can be easily used with this tool. Let's go back to PowerPoint. Yeah, we already discussed about Confluence Builder. I also put some information about extensions that we saw. Confluence Builder, MiramID, it helps to create diagrams from the text. Draw.io, which allows to import in your documentation quite good diagrams. PlantUmail also supports to create UMail diagrams in the documentation, and Sphinx Git, which this extension I saw you a 1 minute ago. Let's go to the next slide. Here you can see just examples who in real world also use Sphinx. And the first one is Molecule. If you're not familiar with it, it's a test framework for Ansible. As you can see here, they use also the same schema as we use for our documentation, just changed the color, but in the end it's the same as we used. That's my presentation. Presentation. Go back to presentation. Okay, Python 3 they also use for generation of Sphinx, and yeah, why I put these 3 examples here, because they have different themes. Oh, sorry, something goes wrong. Oh. Difficult when you use different screens. Yeah, this is Sphinx document. This is Python 3 documentation, which was also built by Sphinx, and you can find this information in the right corner. Yeah. You can see here, created using Sphinx 4.5.0. It looks different, but in the middle you have the same tool which was used for generation. MongoDB also use Sphinx, but it looks totally different than previous 2 websites. I don't really think that they have a pointed version of Sphinx that they have to use for generation. But anyway, they use it. Some more examples you can find following the link in the bottom of this slide. You can find the full list of projects who use, public projects who use Sphinx for generation documentation. I suppose it's a time to ask questions if you have them.